Hello again, it's Jason from STEMonline.com, where we specialize in helping students, enthusiasts, or even teachers with advanced mathematics and physics problems. For anything about this specific area of education, you can always send me an email, or you can ask me in the chat below in YouTube for any advice on anything. Okay, so we're going to continue with mathematics, specifically logic. As I mentioned in the last video, I am going to focus on this specific area of math because it's fundamental for more advanced math courses for those of you who are taking university math or physics or even computer science. Actually, computer science is very heavily embedded with understanding logical equivalences or anything to do with logic. Okay, so today we're going to look at this specific problem here. Okay, let's look at proving if the following equivalence is true. Okay, so let's look at this equivalence problem. Okay, so we want to prove we're going to prove that if P implies Q, okay, so if P implies Q and R, okay, right? If and only if, so if and only if P implies Q, okay, so P implies Q, okay, and P implies R, and P implies R, okay. So we want to show that the following logical equivalences hold. Okay, so how are we going to do that? Well, anytime when you're dealing with statements that have to do with logical equivalencies, make sure you make a truth table. First thing is a truth table. But before that, let's label all of our statement variables here, okay? All right, so let's do that. So let P be the first statement. Okay, so P equals the first statement variable. Okay. Q, second statement. I spelled statement wrong. Sorry about that. Second statement. And let R be the third statement. That's on the left-hand side. The right-hand side, either a statement can be true or false, remember? So either statement 1 can be true or false, statement 2 true or false, statement 3 true or false. Now, we have to put in order all of our statement variables in the truth table. So let's make the truth table. So truth table. Okay, so here's our truth table. We have statement P, statement Q, statement R, okay, P, Q, and R, okay, and then we also have to, those are the statement variables, but then we also have the expressions that we have to deal with, okay. We have to put in Q and R, okay, so we need to figure out the table for Q and R. Then we have to figure out the truth table for, let's see here, P implies Q. Let's do P. Actually, I'll put P implies Q first over here. It doesn't matter. I'm just closer to the first statement variable. P implies Q. Okay. P implies R. And then we also have Q and R. Right? Don't forget we have Q and R. Right? So each one of these, as you can see, I put every expression individually, and then I sum them all up together. After that, we have P. We have to figure out what P implies Q and R is. Okay, so P implies Q and R. Q and R. Okay, what that is. All right. Q and R. P implies Q and R. We also need to figure out what P implies Q and P implies R is. P implies Q. P implies Q and P implies R is. And P implies R is. Okay. And then finally, we need to figure out the whole thing. Okay. The biconditional. Okay, so if P implies Q and R, I believe it said. P implies Q and R. Q and R. Okay, so P implies Q and R. Right, all in brackets. Implies Q and R. If and only if. So if and only if, that's a biconditional statement. Whilst I'm setting this up, if you don't know or forgot what a biconditional statement is, please look at your online book or whatever other resource in the theory about what a biconditional is in the biconditional truths table. Then we have P implies Q. Okay. We have P implies Q, right? So we have P implies Q. Okay. And we have P implies R. Okay. And P implies R. Okay. P implies capital R. Okay, so let's put this under some sort of heading here. Okay, so everything is organized. We have our columns with each respective expression and variables. Okay, so the next thing is to figure out how many true or falses we have for P, Q, and R, only those ones, okay? And if you remember what I mentioned in the last video, right? The way we determine that is that each statement variable, P, Q, or R, can either be true or false. So there's only two options. So base 2, okay, so start off with that, that's our base. And the number of statement variables that we have is our exponent. Since we have P, Q, and R, 3. So 2 to the power of 3, total of 8. 8 is the total number of the combinations of true and falses, but they have to be split in half, right? And the reason why it's split in half as 4 truths and 4 falses is because of the fact that you can only have for each statement variable a true or a false, right? So it's like saying a 50% chance of either true or false. Okay, so let's look at statement P. If you look at statement P, right, it will be true, 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 only 4 truths because the other half has to be falses. False, 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 false. They sum up to 8. Next one for Q, true, 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 false, 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 false. R again, true, 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 false, 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 and then false. Okay. Now we need to figure out what the other expressions are. Okay. They're either mixed with implications, implication operator, and operator, or the biconditional operator. Okay. So, looking at the implication here, right? So P implies Q. Look at the first row. For P is true, Q is true, so true implies true is true. Again, second row, true implies true is true, true implies true is true, true implies true is true. False implying false is false, false implying false is false, false implying false is false, false implying false is false. For P implying R, that's again going to be true, because true implies true is true, true implies true is true, True implies true is true. True implies true is true. False implying false. Be careful. It's always true. If something is false and it implies that it's false, right? Therefore, the final conclusion for the argument is that it has to be true. Okay. Because if something is false and remains false, that is true. So false plus false true, false plus false true, false plus false true. Okay, so P implies R, we know what it is. Next is Q and R. So if you look at Q and R, true and true is true. True and true is true, true and true is true, true and true is true, true and true is true. Okay, so we have 4 truths. Now for Q and R, right, for the falses, false and false has to be false. 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 Okay, so we figured out what Q and R is. Next, we need to figure out what P implies Q and R is. Okay, so looking at this guy, I'm underlining so you don't get confused, and this guy is. So if P is true and Q and R is true, true implies true is true. True implies true has to be true. Okay. True implies, yeah, true implies true has to be true. True implies true has to be true. Okay. Now, when we start with the false, okay, false, right? So if something's false, statement P is false, okay? Now, with statement P being false, and then, let's see here, yeah, so statement P is false. I'm trying to lose my rows here. False. Statement P is false. And then Q and R, okay? So we get Q and R. Q and R. So if that happens to be true, right? False implies true has to be true. Okay. Yeah, because this was, why do we have 5 of these? 1, 2, let me some next ones here. Yeah, those are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Too many of those. I had an extra true here that shouldn't be there. Yeah, it's gonna be a total of 8. So be careful. So that means if Q and R is false, right? So here it is. If Q and R is false, okay, and P is false, false implying false, what do you think that is? Well, false and false implying false has to be true, right? We did that last time, so be careful. Make sure you know your truth tables. Okay, so false implying false has to be true. Okay, again, it's going to be false implying false is true, false is true, false implying false is true. 1, 2, 3, 4. 1, 2, 3, 4, a total of 8. Good. Okay, we have that. Now, the next thing we need to look at is P implying Q. That's this guy over here. P implying Q. Okay, so P implies Q, that column with all the true and falses. Compare that with and P imply R. Okay, next, so first P implies Q is true, and P implies R is true, true, and true is true. Okay, so we got that. Next part, P implies Q is true, P implies R is true, true, and true has to be true. Okay, P implies Q, P implies R. Next one, true and true has to be true. Okay. Next one, true and true has to be true. Okay, how many of those do we have? P and Q. 1, 2, 3, 4. 1, 2, 3, 4. We get into 4. Now we're on the false ones. False implying true. Is this true or false? Take a moment to think about it. If you have something that's false and it implies that it's true, is this false or true for the statement? Okay. Turns out it should be true, right? Right? So it's true. And if you don't believe me, go to the side here. Look at false implying true. This can be written as saying the negation of false or true, right? Because P implies Q is logically equivalent to saying negation of P or Q, okay? Then if you substitute what P and Q is, right? P is false, Q is true, negation of false has to be true, true or true is equal to true. Okay, 2, 3, 4, 5. Okay, so we have that. False or false, where are we? So we were looking at P implies Q and P implies R. P implies Q, P implies R. False implies true. False implies true. That's true, that's true, that's true. So the remaining is true. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. Okay. And we are off to our last column. Okay, so let's see if this matches. Okay. If P implies Q and R, right? Look at P implies Q and R. That was true. Okay. Now be careful, this is a biconditional. So there's 2 steps to this. There is P implies Q and, right? P implies Q and R. Okay, so P implies Q and R. Okay, that's the first part. But then you also have to be looking at and P implying, right? So P implying implies Q, Q, and P implies R. Now, I don't mean this as an AND operator. That's my mistake. What I'm saying is that we have to look at it at a forward direction and as a backwards direction. So one going like this, and the reverse, right? So I might as well put it over here. I think it'll be better if I put it like this. So this is what I'm trying to say, okay? What I'm saying is over here is that if you look at P, right? If you look at P implies Q and R, okay? Q and R, if and only if, right? It's P implies Q, P implies Q, and P implies R, then this is equivalent to saying that P implies Q and R, okay? Which implies, right, the forward direction. I'm taking off one tail for the biconditional of P implies Q and P implies R, okay? That's one case. And we also have this. P implies Q and R, the reverse. That P implies Q and R, then P implies Q and P implies R is the reverse of implying P implies Q and R. Okay, so now the arrow is going the other direction. P implies Q, parentheses, and P implies R. Okay, so you have to do both cases. Okay, so if you look at the first one, okay, right, so we have to look at the first one. If P implies Q and R, okay, P implies Q and R. So that's this guy over here. And then we have to look at P implies Q and P implies R. Okay, I know this is a lot, so we have to go slowly. P implies Q and R, what was that? This was a true statement, right? That was true, first part. Okay, actually I'll put it over here. Yeah, you can get easily lost in this because it's very long. So, over here, right, this is going to be true. Okay, so over here, let me put it. This is going to be true. Okay, P implies Q and R is true. Implies that P and Q, implies that P implies Q and P implies R. Let's look at P implies Q now. P implies Q is also true. Okay, so P implies Q is true. And P implies R is true. However, though, that's only the one direction, right? You'll notice here that we have to compare this and this. Then we have to do P implies on parentheses Q and R. That's true. The reverse implication of P implies Q and P implies R. Again, this is true. This is true. First off, what's this resulting? True and true is true. Okay, so this whole part is true. And now we use the AND operator. We evaluate the second part. True and true implies true. So this gives me, so now I have true for this one and true for that one. Then I get the resultant, true and true is true. Okay? So that's how we do this. And so there you go. Okay. Then we have to look at the next one, right? Again, I already know automatically the next three have to be true. Okay? And the reason for that is if you look at P implies Q and R, right? If you look at P implies Q and R. So if P implies Q and R, these guys here were all true, if you remember, right? These guys here were true. Right, so P implies Q and R is true. And then we had P implies Q was also true. Yeah, P implies Q was true. P implies R was also true, I believe. Yeah, for the first four. So you can automatically deduce that fast, that the first four have to be true. Okay, now the next four. Okay, so looking again at P implies Q, well, P implies in parentheses Q and R. So when P implies parentheses Q and R, so let's look at that column, Q and R. Well, those all were true. Oh, good. So those all were true. The last four were true. So P implies Q, this is true. We know that P implies Q, the last four were false. Okay, so now we're going to be dealing with something like this. It's going to be true implies, right? Because remember, we have the double tail of the conditional, so it's a biconditional. Okay, let me go down here and start replacing some stuff, because this is going to be a little bit, the expression is very long. Sorry about that, and that's a part of math. Okay. Try to erase anything I don't need here. Ah, damn it. Come on. Okay, so yes, we have this. Get rid of this because we're dealing with a new statement here. Yeah, that. Okay, get rid of this. Get rid of this. Get rid of this. Okay, so we had P implies Q, and that was a true, and then after, so this was true for the last four. Okay, P implies Q for the last four is false. All right, so far we're looking at this. Okay, we're looking at P implies Q and R. This whole part here was true. 2 implies Q is true. P implies Q was false. P implies R, the last four, was true. Okay, so let's evaluate what that is. So we're getting here, right? We're getting here true implies false and true. Well, false and true, what is that? False and true has to be false. You can't have something that is true and false. It doesn't make sense. So therefore we have true implies false. Now what does true imply false equal to? Make sure you understand your truth tables for the implication. If you look at the implication for P implies Q, that truth table, on the third line where you have true implies false in your online book or resource, true implies false is false. Okay? So this has to be false. So that means that this whole thing is false. False. Okay? Automatically this is false. Okay, so that means that this is equal to false. And over here, then we do the reverse. Okay? Right, so we have the reverse implication now. So this again, this is still true. This is false. Okay, and this whole thing was true. So now we're looking at it from right to left because we have a reverse implication. So that means we have false and true, false and true, false, right? This portion here is all false. Now we're saying false implies true. Well, false implying true is true. We talked about it earlier. That's true. Okay, so I now know that this whole thing is true. Okay. And since we have an AND operator for the biconditional, right? Okay. That means that we have false and true, right? False and true. What is that? That's false. Okay, so the last four are all falses. Okay. And as you can see here, right? Let's see your equivalent. Okay, so if you look at P implies Q, and P implies R, right? So we have the whole thing. This whole thing was true, 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 false, 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 false. Okay, for that column. Okay, and P implies Q and P implies R. Let's see, P implies Q. True, 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 and you can see that they line up. Okay, and that's how we get the final column. We have to make all of these things and compare, right? True and falses. I hope you enjoyed this video. Don't forget to like and subscribe, and there'll be plenty of more math videos coming very soon. Have a great day. Bye bye.